One of the most notable developments in science in the last decades is the creation of computer algorithms to process and analyze huge amounts of data. Some contemporary scientific research produces so much data that it would be impossible to work with using traditional means. So scientists have developed algorithms to do the work for them. These algorithms are essentially programs that learn on their own to identify patterns or trends in data. For that reason, they are called machine learning algorithms and sometimes artificial intelligence or AI. Machine learning algorithms need to be trained in order to learn how to identify the kinds of patterns that researchers are interested in. So, when developing the algorithms, researchers use training datasets. Then the algorithm will apply that trained behavior to a new dataset, hopefully identifying the same kinds of patterns. For example, a researcher might be interested in having a machine learning algorithm identify a certain kind of galaxy from images taken from all of the available data from all of the world's telescopes. In order to train the program, they would give it a sample set of data, where images of the kind of galaxy they are looking for are classified one way, and images that do not contain the kind of galaxy they are interested in are classified another way. The algorithm would have certain features that would allow it to develop a classification scheme based on the patterns it notices in the target images. Then, when it encounters a new dataset, it should be able to sort them into the appropriate classifications that it learned from the training data. The power of these machine learning algorithms is that they enable scientists to do kinds of studies that were previously impossible because they involved too much data. Now researchers can look for patterns in internet searches, social media posts, or digitize the historical records. Machine learning algorithms have been particularly successful in medical applications because they can compare the appearance of a skin lesion, for example, to a huge database of other images and more accurately determine if its appearance is indicative of cancer than a doctor can. Machine learning algorithms also play a role in everyday life. Many internet services use algorithms to learn about their users' preferences and direct them to pages that they might be interested in, promote or demote certain content, or show them ads. Some services use machine learning algorithms to connect people to each other or job seekers to employers. However, this broader reliance on machine learning algorithms introduces certain risks. Biases can be built into the algorithm either through the way it is designed or the data sets it gets trained on. For instance, there seems to be promise that machine learning could eliminate bias from hiring decisions. So many companies adopted the practice of having job applications ranked by algorithms. But there have been many examples where the data sets that the algorithms were trained on embodied many of those biased decisions themselves. So the algorithm learned what a good candidate looked like based on the very kinds of problematic decisions that the companies were attempting to eliminate in the first place. Another risk is that these algorithms are usually the intellectual property of companies that develop them. The exact way in which they work is not public knowledge and therefore not subject to the kind of scrutiny that typically happens in science. A new method for experimentally establishing a relationship between two variables would usually need to be peer-reviewed to ensure that the correlation it purports to show is real. This would involve other experts in the field thinking hard about the choices that were made in the experimental design to assess whether the new method is showing us something meaningful about the relationship between the two variables, or if it is just churning out spurious correlations. But in the case of proprietary machine learning algorithms, that might not be possible. Machine learning algorithms can assist scientists in analyzing large data sets and finding correlations that would otherwise be impossible to see. But they cannot replace the work of scientists in some key areas of research. Much of science is hypothesis-driven. Coming up with hypotheses involves creativity and scientific intuition, and the outcomes of observations are used to help scientists determine whether their hypothesis is correct or whether it needs to be changed. This process can rely on theoretical background knowledge, creative problem solving, and making value judgments. Applying machine learning algorithms to simplifying patterns in data cannot replace this rich process. While machine learning algorithms show great promise and do enable scientists to conduct research that would otherwise be impossible, they aren't a panacea. Because of the sheer amount of data involved, there are ethical issues that arise that must be carefully attended to. Ensuring that the design of the algorithms themselves and the data sets on which they are trained do not embody problematic biases is necessary for ensuring that this new technology produces good outcomes in the future and doesn't simply reproduce the problems of the past. This is made more difficult by proprietary machine learning algorithms that are not open to scrutiny. And there is no reason to think machine learning can replace the ingenuity and creativity harnessed by science.